Hello. My name is David. I'm based in London. I work as an information designer and data journalist. And that basically means I spend my time gathering all kinds of data, information, knowledge, numbers, statistics, words, and then visualizing it in graphical images that anyone can understand. And I like to go a little step further and take this visualized data and design it so that it reveals something interesting or allows us to focus on something important in the sea of data surrounding us that we're drowning in. Also that it tells a story. And I think when you do that, when you gather data, analyze it, visualize it, and design it, strange and interesting and even quite magical things can start to happen to your data. So I want to show you a few little things that I've done in this field, and you can see what you think. And I'm going to start with a data set that I think we can perhaps all relate to, or maybe struggle to relate to, and that's billions. So what does $1 billion look like? What does $100 billion look like? What was $1,000 billion look like? These numbers are routinely circulated in the press and in news reports and so on, but we don't actually know what they mean. They're so mind-bogglingly huge, we can't get our heads around them. So frustrated by this personally, I scraped a load of these numbers together and I visualized them in this diagram here, which I call the billion-dollar-ogram. And here the blocks are scaled according to the numbers, and the colors represent the motivation behind the money. So green is revenue, pink is giving money away, and so on. So immediately, when you visualize numbers in this way, you have a different kind of relationship to them. You can literally see them. But more interestingly, you can start to see patterns and connections, relationships and links between data points that would otherwise be scattered across multiple sources that you'd never see together. Like in this little square here is quite interesting. This is the amount given to charity by the American people every year, $300 billion, very generous to the American people. And you can contrast that with the amount given in foreign aid by the top industrialized nations of the world, just 120 billion. And in the top left, of course, we have the cost of the Iraq war to date. And a little square in the corner is its predicted cost back in 2003 when it was started. So that's mushroomed a little. So often that's where the interesting stuff is in your data, not in the data itself, but in the gaps, in the links and the connections, the patterns between them. But still I look at this diagram and I struggle a little bit because I see billions and I still can't get my head around them. So I wondered if I could take this a step further and convert some of these numbers into a metric I can more readily relate to. So I came up with this. So these are some of the numbers in that diagram converted into how much the average taxpayer contributes to each silo per day. And my thinking here is, I don't know exactly how much I spend a year or a month, but I know how much I spend a day. That's a number I can relate to. You can see a little snapshot there. In America, you're actually the only country that spends more on your military defense, $2.10, than you do on health. So it gives you a different picture. And there's not a lot of visualization going on here, so the version in my book actually looks a bit like this. So you can see the flows and the ins and outs, and you can explore it. It's like an information map that you can find your own connections and patterns. So that's one of the potentials of visualization, is to bring your data down to earth. And often when I'm doing this, I feel like a true member of the media, like a data journalist. I feel like I'm mediating between the vast seas of data on one side and everyday life on the other. So, as I said, I worked as a journalist. I worked as a print journalist for a while as well. And what I discovered very quickly when I entered that field is that something propels stories, something makes a really great story in the press, and that's fear. Fear is a great seller of newspapers. And it seems that we're scared of something. We always need to be scared of something. So I wonder what a timeline of our biggest fears might look like. And this is how I visualized it. So I'm going to enable this for you. Along the bottom, obviously, we have time. And the height here is the intensity. The number of times each of these fears has been mentioned in the press. Pink spike on the right, that's swine flu. The yellow, that's bird flu. Orange is SARS. You remember SARS? The gray spike on the left there, that's the millennium bug, when we were terrified of our computers crashing. The light green foreground spikes as asteroid collisions, the fear that we're going to be hit by a passing asteroid. And the dark blue humps in the foreground, killer wasps. So these are our fears as they rise and fall in the group mind, if you like. And of course, recently we had a terrible fear, a terrible scourge, the scourge of Ebola, which I can add to this diagram. There it is. There's the Ebola spike. In fact, it's so huge and off the map that if I scaled this diagram to accommodate it, it actually looks like this. So this is a story there about how our fear is just getting greater and greater and greater. And it's not a pattern you could see in a spreadsheet. You need to visualize it to be able to see it. So let me show you another landscape now. This next image went a little viral, so some of you might have seen it before. So if you know the answer to this, don't say. But I want you to try and guess what this data set might be. There's something that peaks twice a year. Once around about Easter, then 2 weeks before Christmas, has little mini peaks every Monday, and then flattens out in the summer. Any guesses? I don't think I can be able to hear you, actually. Just imagine in your mind what that might be, that data set, Mumbai. Yeah? Oh, very good. You've seen it before. It's actually, most common breakup times according to Facebook status updates. We scraped 200,000 of them, and this was the pattern that was revealed. A mysterious peak around April Fool's Day. Mondays, we think people come out of weekends, terrible, they've had a bad weekend, and they update their status. The spike for summer, you want to be young, free, and single in the summer, right? So a little clear out there. The lowest day of the year, of course, Christmas Day. Who would do that? So we're generating so much data every hour, every minute, every millisecond, Twitter, Facebook. It's creating this vast ocean of data. And one way of dealing with that ocean is to have a good question, having a good inquiry. And if you ask the right question, it maybe reveals some gold to you. There's a phrase I hear a lot in this world, data is the new oil. This idea this ocean is like a ubiquitous resource that we can mine for insight and innovation. And I think it's a good metaphor, but I would adapt it slightly, and I would say, at least for me anyway, data is the new soil. Because for me, it feels like a new kind of material, something you can gather and get your hands dirty with and dig through. And if you kind of treat it in the right way and you fertilize it in the right way, then visualizations and infographics, they're like flowers that can bloom from this soil. Of course, we have a name for this soil. Some of you may have heard of this phrase. Anybody heard of big data? Anybody in this room? Yeah. Now, I didn't use this word for a long time because I was confused by it. I didn't quite know what it meant. Obviously, it's a buzzword. And then it struck me, and then I realized, actually, you know why? Because it's a noun, but it actually describes a process. Big data is a process, so it's a verb. And it involves all these steps, the gathering and the handling of data, the structuring and examining of that data, and then discovering something about that data and delivering it back into your organization or into your team or whatever. Now, I've drawn a line there because I meet a lot of individuals and a lot of companies that are cycling round in the top half of that diagram. They're gathering huge amounts of data, they're warehousing it, they're structuring, and they're doing a bit of analytics on it, but they're not really penetrating to discovery. They're not really finding that much out and not able to roll it back in. And that's when the journalistic techniques are helpful, having a good question, following an inquiry, starting that, because open the data box and use the question as a thread in. A lot of my work starts with a question. Like, as a recent question I was playing around with, do horoscopes all just say the same thing? Now, I don't know much about horoscopes, but that's the rumor. So I scraped about 80,000 of them from Yahoo's horoscope database, and I came up with this. This is a most frequently used words in all horoscope signs chart. As you see for yourself, where they say the same things. And the red words here are strongly unique for each star sign. So any Taurians in? Anyone Taurus? Yep, well, about 11%. You are open, but you worry a lot, according to the data. Any Virgos? Oh, well, 15%. You are totally perfect. That's what the data says. Now, if you're interested, by the way, in scraping data from Yahoo's server, you can get a developer. He doesn't have to be Russian. Mine happened to be, and he wrote me a nice Python script which pinged Yahoo's server and scraped all this data into a big spreadsheet. Now, the problem is, if you ping Yahoo's server too quickly, it thinks you're hacking and it bans your IP address for a week. So after 3 weeks, we found the ideal frequency to not trigger that, and it's 1/10 of a second, so just in case you're planning. Okay, so I visualized this chart, and then I thought, hold on, I can go a step further. I've got the most common words across all star signs, so I can create a single prediction, a meta prediction that will apply to every single star sign, every single day of the year. You need never read a horoscope again. So here it is, the most common words across all of them. Make this. Whatever the situation or secret moment, enjoy everything a lot. Family and friends matter. Keep making love. The world is life, fun, and energy. May be hard or easy, but just change your mind and a better mood comes along. There you go. You need never read a horoscope again. Thank you. Now, this is just a funny side project, a frivolous thing. I was having fun doing it, but it was interesting. I was playing around with the data. I picked up, I learned how to do word frequency analysis. I got a great relationship with the developer. I did the chart. I did the further analysis. So I picked up a load of data skills through playing with data and visualization, and I can now use them in my commercial projects or for whatever I want to do. So playing with data is actually a really great way of learning how to handle it, learning how to get the best results out of it. Allowing yourself creative play, you get good results. And then sometimes you just want to use data visualization to make things look better. The design bar in the culture has risen massively. Anything you create visually has to compete with everything everyone has seen before. So visualization is a great way to add a bit of punch. I did this project. This is a lab report from a blood test unit. A clinician has done a blood test. And we had a challenge from Wired magazine. Can we bring visualization to this to make it appeal to the patient and the clinician and the doctor? So we visualized it like this. So we introduced hierarchy, color, context, pictograms. So suddenly it's something that can speak to all three of those elements, those people, in one go. So that's a great way of lifting your content. And then frustration is often a big inspiration for me, and I've been very long time frustrated by this, the cosmos, the heavens, which we always depicted as little points of light. I mean, obviously how it looks. But that disguises the incredibly rich flora and fauna that exists in the cosmos. Black holes, molecular clouds, supernovas, blazars, quasars. So there's a whole garden of different entities that exist online. So I catalogued them all, gave them each an image, described them all in 4 lines or less, quite challenging. Then it gave me a visual vocabulary that I could then present back onto the heavens. So these are the constellations mapped with this symbolic language. You can zoom in and see the variety and the difference. And it gave me the opportunity in a language to then re-render the Milky Way. This is the Milky Way, the composition of the Milky Way in this visual language. We've got a lot of red dwarf stars in our galaxy because it's a very ancient galaxy. It was born very shortly after the Big Bang, 13.6 billion years ago. And there's the Andromeda galaxy alongside it. That's the nearest one next to us. It's twice as big and it's very much younger, and the stars are blue because they're hotter. So visualization can be used to open up quite a dense and complicated subject area such as astrophysics or cosmology and just create a portal into that subject matter. You can now just look at it, enjoy it. So information is beautiful. I wondered if I could make my life beautiful. Here's a little snapshot of where I've come from. This is my visualized CV. I was a programmer in my teens. Then I got into journalism. I was very much into video games when I was a kid. So I wrote about video games and followed that trend in. Got into online, worked in advertising for a while. Advertising, long known the power of the visual image. I learned a lot from them. And I've been designing for about 5 or 6 years. Done a lot of work in my career. The thing I'm most famous for, though, I think, is this. Anybody recognize this? Yeah. Well, it's actually a rip-off of something I created, which was this. Does anybody recognize the helicopter game? Put your hand up if you recognize the helicopter game. Fuck, wow, cool. Yeah, 30% of you. Yeah, thank you. Just wanted to put that out there. Now, anyway, I draw attention to the little green column on the left there. So, designing for 5 or 6 years, never been to design school, never studied art. I like to learn by picking things up and just playing with them. And what was interesting, when I started designing, I discovered something about myself. I already knew how to do it. Not like I was really good at it, but more like I had a sense of color, space, and typography. And I think because I've been exposed to all this media in my career, it's sunk in. I had an innate design literacy, and it was just waiting for expression. And I don't think that I'm unique. I think this is happening to all of us. I think every day we're being exposed to an information design medium, the internet, and it's training us to relate information and design together, to expect the two to come together. So much so that the authority of one now depends on the other. So think about where you visit a badly designed website, how little you will trust the information on that website. Visit a glossy website, how little you will question the information on that website. So the two go hand in hand now, design and information, visualization and data. And I wonder if there isn't something cognitive about this. You know, our minds are exquisitely sensitive to color, shape, and pattern, our language of the eye. And if you combine that with the language of the mind, like numbers, ideas, and shapes, as you do, you're able to speak 2 languages simultaneously. 3 out of 4 neurons in our brain is dedicated to the visual system. So you've got 2 languages, the language of the eye, color, shape, and pattern, language of the mind. And that's what you do in an information visualization. You use both those languages. Let me give you an example. Here's a little snapshot of currently what's happening in the telecoms industry. bit of a bun fight. Let me just explain this diagram to you. The blocks are yearly revenue, the size of the companies. Red companies have decreasing revenue year on year. Black companies have increasing revenue year on year. And then the speech bubbles are the reason why each company is suing the other. So I can filter those out. We're dropping down to more of a visual layer. We can drop down further. We take the company names off. Now we're just on the visual layer. Now just on the language of the eye layer. And on this layer, your eye is exquisitely placed to answer two questions. Is there a relationship between decreasing revenue and increasing litigiousness? Is there a relationship between the size of a company and increasing litigiousness? Again, not a pattern you could see in a spreadsheet, but here you can see it immediately. You layer on some concepts, you layer on a story, and suddenly you've got an image that's working on multiple layers simultaneously. And if it's designed well, if it's harmonic, then those layers shouldn't interfere with each other. So you can ingest it in detail, or you can sit back and just take it in. So that's the power of visualization. I think that's why it's often related to as a new kind of camera, like taking snapshots of your data. That's a great way of thinking about how you're going to use visualization in your data. Like, what kind of shot do I want to take? A wide shot, a zoom, a satellite photo? How am I going to compose it? How am I going to frame it? A satellite photo is a good shot, and you see this a lot using geo. So you can see a lot of your data, the layout of your data. This is a little sequence I did for the UN. They had some very boring data about the biggest drug-using countries, illegal drug-using countries per head. So I took some of that data, and this is what I came up with. So this is a tour of the biggest drug-using countries. This is cocaine, little snapshot. Then we have cannabis. You're going to see a lot of Australia in this. Sorry. Any Australians here? Yeah, just clinging on. We have, that's your ecstasy. Then we have amphetamines drifting east a bit more. Then we have opiates. It's a sadder picture. And nicotine addicts. And then finally, the drunks. So there you go, a little story of drug use around the world. And so you needn't always show your entire data set. You don't have to show all your data. Sometimes the story is in the top layer. It's worth seeing. So you can do a wide shot like this, or you can do a crash zoom. So you can just zoom down into a little set of numbers or a bunch of statistics that can reveal a lot about our whole world. This is a little graphic I did around Twitter's IPO a couple of years ago. 283 million users at the time. You know, how many of them are active in a traditional sense? And then I was reading a book by Clay Shirky, some of you might know, a New York academic, Cognitive Surplus. He has this standout statistic. 200 billion hours spent watching TV by US adults, contrasted with the 100 million person hours it took to create something as awesome as Wikipedia, just as a symbol of our potential. This is an interesting image, actually, because I sketch a lot of my images before I create them. This is my sketch. And as you can see, 100 million, it's a lot of money. It sounds like a lot, and I had scaled completely out of proportion, like the billions. But that made me think, I wonder if that's used. So I had a look around, and I found this. President Obama announced the federal budget of the United States, $3,500 billion. That's the amount of money needed to run the government apparatus of America. And at the same time, he said, well, it's a time of austerity, so I'm going to cut 100 million. And everyone's like, yes, 100 million, excellent, good, yes, let's cut 100 million. So let's do that, shall we? 3,500 billion US federal budget, which, by the way, is not just shy of the economy of Germany. So 3,500 billion, and let's cut 100 million. So imagine in your mind what 100 million might look like. Let's cut it. There you go. Now, is that fair? Is that a good cut? Yeah. So zooming in. And then with this camera, you can also go wide. So sometimes you want to show all your data, and sometimes you need to see it all in order to tell your story or to just reveal the beauty of it, really. This next diagram I didn't create, but I wish I had. It's a beautiful piece by Nick Berry of Data Genetics, and it's most common PIN numbers. If you give people 4 digits to choose from, this is what they choose. This is from a data breach. So along the left, we have the first 2 digits, and on the right, we have the next 2 digits. That diagonal line in the middle is people using double digits, 1111, 2222, 8888, and so on. The horizontal line is people using their birth year. That's the 19 line, so 1921, 1971. And then the heat map in the corner is people using their month and day, their birthday, month, day, so it doesn't go over 31. And out of this data arises the 3 most popular passcodes. 1, 2, 3, 4, 4, 3, 2, 1, and 2580. Why 2580? Straight down the middle. I just love it because it's like a symbol of our predictability. And the wide shot actually brings me to the theme of my current book, which is Knowledge is Beautiful, where I'm looking, one of the themes is like, what is the difference between data, information, and knowledge? And how do you transform one into the other? And part of the exploration of the book is seeing how you do that. And you start with data, and as I was saying, data is like soil. You know, if you visualize it as a substance, it's like soil, it's like little dots, particles, it's particulate. And if you gather it and sort of structure it, you get another substance which you could call structured data. So it's like spreadsheets, databases, and so on. And that needs to be filtered and interpreted. And then you create something that's digestible that you can communicate, which is information. So it comes in bytes and blocks, you know, bytes of information. Recently, we've been able to dynamically link that information. So now we've got this linked information like hypertext and web stuff, which is great, but it's not yet knowledge, you know, in the way that the web is not yet knowledge. So you have to take another step. You have to get all that data and information. You have to pack it inside one thing, like a cell. So knowledge is actually very cellular. You packed all the data and knowledge inside it. Sorry, the data and information inside it. And then if you connect cells of knowledge together, because you could talk about a body of knowledge, you get something that's a bit more organismic. It's interlinked. It's connected. And this is quite magical, this interconnected knowledge, because you can use it to model reality, to do predictions, predictive analysis, and so on. So some metaphors are quite useful here, I think. Data, it's like atoms. Then we've got structured data as molecules. Then we have DNA, strings of information, right? That's linked up together in chromosomes. Chromosomes are packed into cells, and cells link up together to form organisms. So it has that sort of flow around it. And knowledge has its own qualities. One of the things it likes to be, if you talk of it in that way, is it likes to be comprehensive. Like you need to get all that data and information inside it for it to become knowledge. So it's comprehensible. So it's comprehensive. So in my book, I found that every diagram I created, I had to pack in all the information and data there was around it. So I had to do all the cooking oils and visualize all the sugars, all the antibiotics and their resistances. You know, every single plane crash of the last 30 years and the causes, pink here, it's human error. Every single cause of death of the 20th century and how many people died. Every single empire and how long they lived. Every single near-Earth object that might pass by the Earth in the next 150 years, all 1,400 of them. Every single journey in time travel and film. Every single dog or popular dog and how awesome they are or not. And then every single nutritional supplement and the evidence for it. This was spawned out of a bit of a health kick I was on a few years ago. This is a balloon race, this diagram. The higher up the diagram, the more evidence there is for supplement. The size of the bubbles relates to their efficacy. We scraped thousands of studies and we're able to draw a line and diagram and say, these are worth taking. And these aren't. That's about 87% of substances don't pass the clinical threshold for evidence. Very frustrating. Spent a long time creating this image, 3 months. I had 8 months to create my first book, and after 3 months, I just filled 2 pages of my book. But it's good because I packed a load of information in this. It's like the MP3 of knowledge visualization. You can condense so much down in a small space. And we curated the data very carefully, and that allowed us to then build on top of that, build apps on top of it, so build some interactives. And when you're dealing with knowledge, I think stuff needs to be interactive because it's so dense and intricate. So this is the interactive version of this snake oil. It's plugged into the spreadsheet, so as soon as a new study comes in, I can update the spreadsheet and it just instantly ripples online. And of course, because it's interactive, we can do some filtering. And we can say, look, just show me the stuff for, say, diabetes. Roll over and filter. Or cancer, and so on. So we can do a lot of filtering. And I applied this same lens to the world's biggest data breaches, a scourge that we're all terrified by, I'm sure. So these are the world's biggest data breaches of the last 10 years. Quite a few, as you probably heard, and maybe been a victim of. And again, with this approach, you can do some nice little filtering. So we can say, let's have a look at healthcare. As you can see, healthcare had a very bad year around about 2009, 2010, but it seemed to have tightened their security since. And then in tech and web, getting pummeled. Quite a lot of tech and web breaches going on. So you can explore this and find your own story. That's the joy of interactivity. So you can offer it in a certain state and then allow your customers or your team or whoever to just play around with it, find their own stories. And it helps me because sometimes I'm faced with stuff I can't understand like this. This is all the relationships in the Middle East. This is love and hate in the Middle East. Pink is love, black lines are hate, and dotted lines are complicated. And it's interactive. We can roll over. Is it going to play? Doesn't look like it's going to play. You can roll over, see different relationships, filter it, and so on. And the opening state here is a bit of a visual joke because I wanted to show how complicated this region is and how it defies a simple solution. You can see who hates whom. So that's just a little tour of some of the potential when you visualize data, information, and knowledge. I wanted to leave you with maybe a little guidance if you're interested in getting into this field or you're already practicing and you want to do more. Oh, it's this diagram, isn't it? Oh, okay. I'm running out of time, I'm afraid. So I wanted to say around this that a lot of our data is quantified data, which you can also visualize qualitative data. So, people's opinions, sentiment, ideas, and other things that lends itself to visualization as well. So you can do that too. You can check this online. They're all online. It's the political spectrum. So I just want to end with a little system or something I think what makes a visualization really work. So 2 elements, obviously data and information, those 2 things fit. And the 2 missing implicit elements are a story and a message and a goal and a purpose. And these add, the data makes it trustworthy, the story makes it interesting, the goal makes it efficient, and the visualization time makes it impactful. If you combine all the 2 together, you get a successful visualization. Okay, I'm done. Thank you. Enjoy that.